Right, welcome to the first video that I'm going to do on all of the chips that you need to know, okay? You've done this one before. These are the 5x5 timers. Remember, there are two versions of the 5x5 timers. One is the monostable, and the other one is the A-stable. Both of these names should ring a bell to you. So if we look at the chip first of all, this is, these two here are the chip in real life, okay? So that is the package that they come into, and this is actually how they're laid out. Every chip always has a little notch at the top that tells you which way around it goes, and often a little dimple there to show you where pin 1 is. We always have all of our pins labelled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 going down this way and back up the other side. So here it goes 1, 2, 3, 4, 5, 6, 7, 8. Always numbered anti-clockwise. It doesn't matter if this is an 8-pin chip or a 28-pin chip or a 40-pin chip, it will always go that way. Over here then, we have got a circuit symbol. It's a much more basic version. We'll look at how to put that into a circuit in a second. Alright, but this is all you really need to know. Yet they're all labelled. Pin 2 is commonly the one that's you're going to get asked about, which is always the trigger. It gets things going. Okay, ground or 0 volt, and 8, which is the power supply, and then output. Okay, those 4 are the most important ones. You may get a question asked on the rest of them, but it's highly unlikely. So, for monostable, this comes on for a fixed amount of time. Okay, for example, out in the corridor, you might be there in the corridor at night. All of a sudden, you come out into the corridor, the motion sensor triggers you're there, the lights go on for a certain amount of time, and then they go off. They don't get triggered again until you go out into the corridor. Okay, the A-stable, on the other hand, switches something on and off continuously. It flashes. An example of that might be the emergency lighting you get on a motorway sign to show there's a hazard. It just flashes on and off until somebody pulls the power. All right. You're going to need to know the circuit diagram for both the monostable and the A-stable, and to get those higher level points, you'll need to know the equations. They are written in the front of the exam. You just know how to use them. Okay. So T equals 1.1 times C times R. Remember, C and R, this whole circuit is linked to capacity and resistance, okay, and they affect the amount of time. Okay, so this is for the monostable, all right, it's the length of the monostable time period, all right, and then the other one is frequency. That's the frequency between the flashes on and off, all right, and it comes with the equation 1.44 over, open brackets, R1 plus 2 times R2, close brackets, and you times all that by C, the capacitor, and that's the frequency. Now, frequency is the number of flashes or pulses per second, okay, and it's measured in hertz or Hz. Time is obviously measured in seconds, all right. The two graphs sometimes come up in the exams. This is the monostable. Again, we know that the signal comes out as either 0, off, or 1, on, okay, and at some point, we don't know when, it will be triggered, so it goes on for a certain amount of time. And we can calculate time or change the time by changing the resistance or the capacitor. Over here, we've then got the pulses. Okay, the minute we turn it on, it flashes between 0, 1, 0, 1, 0, 1, and that's pretty much it. It's worth knowing that the different parts of that graph have different names. If I quickly draw it on the graph over here, you get this graph, which is like the top of a castle. Okay, this is 1, that is 0, 1 means on, 0 means off. This section here, we know as mark, okay, so I'll write that there for you. And the space between the two marks is the space, nice and easy. Alright, and that's pretty much it. So all we've got left to look at is the circuit diagrams. So if I quickly get rid of this, there's a very good chance you're going to get asked about the circuit diagrams for both of these circuits. So we'll start with a monostable, alright? So in the exam, you may be given any part of the circuit. Normally they'll draw the voltage rails in for you. If they don't, you put them in. And they'll draw the circuit symbol. Okay? And they'll label it 5, 5, 5. They will normally put all the pins in there. Okay? And hopefully they'll number it for you as well. I need to remind myself. 4 and 8. 1 and 5. Now this is a circuit symbol. It's supposed to be easy. Okay? If you remember the systems diagram, okay, which goes input, process, and output, we know that's a process. It's doing something, okay? So this is a process. So we know everything on the left-hand side is going to be linked to our input. Everything on the right-hand side is going to be linked to the output. So we know straight away that pin 3 is the output. Even easier than that, if it's on the top, it's pointing towards the positive volt rail. So we connect that straight up. Never forget those two blobs. 1 comes down, blob again, but we don't do 5. Pin 3, the exam question will ask you to connect it to a suitable output component, or will tell you it must be an LED or a buzzer. Make sure you draw it on. Okay, and then we look at the bit that makes it monostable. Now we know that pin 2 is the trigger. We know it said in the exam question, monostable, with mono meaning once, and we know when it's only once, we have to trigger it. So we're going to put in the switch to begin with, and a pull down resistor. If in any exam question it asks you to suggest a pull down resistor value, always say 1 kilo ohm. Nice and easy, you can't go wrong. That connects to pin 2. That's the easy bit, but we haven't yet controlled time. Remember, time equals 1.1 times C times R, so you've got to put those in. C is a capacitor, R is a resistor. Again, in the exam, it'll give you the values for it. So I'm going to put in a resistor here, and I'm going to put in a capacitor there. It might state it has to be an electrolytic capacitor, so I'm going to put that as a plus sign there. If it doesn't, don't worry about it. Okay, and then finally, the only things we're not connected are 7 and 6. Okay, so we're going to connect those into there as well. Okay, R1, R2, and C. That is a monostable circuit. It's really important you learn this one. Okay, all right, because it's a good chance it's going to come up. The final thing, if it didn't tell you a voltage, put one in. Or if it did and it hasn't labelled it for you, put them in. Obviously that's going to be 9 volt, 0 volt. That's perfect marks. Okay. So the final thing we need to worry about is maybe having to use that equation. If it does that, the equation is at the front of the exam. Okay. It might give you a value for R2 and C1. Okay. Or it might have called it R1 and C1, but you know it's going to be these two here. It's those two that link to the timing. Okay, so let's go for an example. R1 is 10k and C1 is 100 mu F. Okay, we can plug it straight into the equation. We know the equation first of all. It's T equals 1.1 times C times R. So now we substitute. T equals 1.1 times 10k times 100 mu F. There's a problem here. You know that we can only work in whole ohms and whole farads. We've got to convert them. Okay, so T equals 1.1. This is the easy one because we know K is 1,000, so it's 10,000 times 10,000. Okay, this is the hard one. Microfarad, as you know, equals 10 to the minus 6. Easy way of doing this then, take your 100, there's your decimal place. The minus sign means I'm going to go that way. So I'm going to go 1, 2, 3, 4, 5, 6. Put in the zeros here, okay, and it's now actually 0.0001. Put that into your calculator, which you are allowed in the exam. Don't be a muppet and forget it. Okay, it's going to be T equals, I'm going to let you work that out. So, that's the monostable. Pause it there, learn that. You need to know it off by heart, okay? It's easy marks. There's a good 8 to 10 marks on that one straight away, and remember, you're all aiming for as many marks as you can get to. So please pause now and give that a go. Okay. Right, the A-stable, the second circuit we've got on that board, okay? As we've just discussed, the A-stable just flashes on and off and on and off continuously. There's no trigger. You've got no input to this one. Again, they may be nice in the exam and give you certain parts of the circuit. Nothing's really changed. It's still the circuit symbol in the middle. Don't know why I rubbed it out. What a muppet. Okay. We know we connect to power first of all with the blobs. Okay. We know we don't bother with 5. We know 3, if they've given us a component, we're going to connect to that. As an example, it might be something different. Okay, as you all know, I've just used a transistor to boost the power, which is now controlling or driving a little buzzer or speaker. This is where it gets different. So I've still got 7, 6, and 2. This gets different. There is no first column, it's all in one column. It's going to be an R1, an R2, and a capacitor. Again, read very carefully. If it says electrolytic capacitor, that will be a little plus sign. All right. This one's slightly different. This time the 7 is on its own, goes to there. Don't forget connections. 6 and 2 connect, and they go to there. When it comes to doing and giving the values, they will always call that R1. That will always be R2, and that will always be C1. Happy with that? Before we go on and do the equation, pause here and learn that one. The important thing is, this is the flashy one, which does that, okay, and just flashes on and off. Okay, don't forget voltage. All right, have a pause and have a go at doing that, please. Okay, so the equation is frequency this time. The first thing we're going to do is going to go to the front of the exam, find the frequency equation, get the mark for choosing the right one. So F equals 1.44 over, open brackets, the value of R1 plus 2 times the value of R2 times by C. It's all there, it will be given to you in the exam. All you've now got to do is plug it in. So that was step 1, plug it in. Okay, so 10 plus, and when you're working in whole ohms, plus 2 times 10k, which is going to be 20,000, times 100 mu f. What do we know about mu f? Microfarads. They've got to be converted. We did it before, but as a little reminder, okay, microfarad, okay, is times 10 to the minus 6. So my decimal place needs to go back 6 times. 1, 2, 3, 4, 5, 6. Okay, and put in the zeros. Okay, and I can times this by 0.0001. Plug that into your calculator, you've got frequency. Remember the units. Hertz, pulse per second. That's pretty much all you need to know. There may be other questions, but a lot of it will be common sense. Use this video, go back through it. If you've got any questions at all, just come and see me before the exam. But that is the 5 for 5, A-stable and monostable, and everything you need to know about it. Thank you.